Hey, welcome to this lesson about using CPCTC. Remember that CPCTC stands for corresponding parts of congruent triangles are congruent. Essential question and objectives. How can we extend proofs using CPCTC? So we're going to review CPCTC and use CPCTC in a formal proof. Our standard: use congruence and similarity criteria for triangles to solve problems and to prove relationships in geometric figures. So CPCTC means congruent parts of congruent triangles, corresponding parts of congruent triangles are congruent. CPCTC for short. It's kind of a tongue twister, so be careful when you try to say it. It's pretty self-explanatory. This theorem states that if two triangles are congruent, then all of their corresponding parts are congruent. But in order to say certain parts of a triangle are congruent, we may need to first prove that the triangles are congruent. So here's an example of a proof you might see. Okay, it has two triangles. We're given that KBC, which is right here, this angle, KBC, this angle right here, is congruent to ACB, which is KBC, this angle right here, is congruent to ACB, which is this angle. Angle K, which again is this angle, and angle A, they are congruent. And with that information, we have to prove that KB is congruent to AC. Now, first you might think, well, there's no way we can do that. But if we can prove that these two triangles are congruent, KBC and ACB, if we can prove that those two triangles are congruent, well, then their corresponding parts will be congruent as well, and we can prove that KB equals AC. So I'm going to start with, like I always do, start my proof with a statements column. And right next to it, a reasons why I can make that statement column. I'm going to start with my given statement. So angle KBC is congruent to angle ACB. It's given to me. Then angle K is congruent to angle A. That is given to me. From there, I can see that these two triangles share the side BC. So I'm going to say BC is congruent to BC, and I can say that because of the reflexive property, which says that anything is congruent to itself. Okay. Now, because I have that, I have angle 1, angle 2, and then a side. Angle 1, angle 2, and then a side. So by angle, side, I can say that in fact that the triangle KBC is congruent to the triangle ACB. And because of the theorem that we just discussed, I can say side KB is congruent to side AC. And how did I know their corresponding parts? Well, if you look at the label, K and B are the first two letters of this triangle, and A and C are the first two letters of this triangle. So they are corresponding parts. So I can say, because of corresponding parts of congruent triangles, we just proved that those two triangles are congruent, are in fact congruent. So that's my reasoning. And there you go. That's how you use CPCTC in a formal proof. Here's what your homework assignment looks like. You're just going to review a couple things: the reflexive property, what exactly that means, and then how you would use it. A little bit of a vocabulary builder. What is a proof? What's the difference between proving something, the verb, and then a proof, which is a noun version? And then using that vocabulary in sentences, which one do you use? Do you use the noun or the verb? And you're going to be given an incomplete proof, and you're going to be asked to fill in the blanks of that proof. So go through that step by step. And then you're going to be given a couple problems where you have to answer questions about proving parts of triangles congruent using CPCTC and some things you already know about congruent triangles, like side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg, and things like that. If you have any questions, feel free to reach out to me on BBIM, text message, phone call, email, whatever's easiest for you. Come meet me in the Math Cafe Monday, Tuesday, and Wednesday at 11 a.m. Or you can meet any math teacher in there every day from 9 to 3 that would be willing to help you with your math assignments. Come see me in live session where we can go through this in a little more depth. That's all I have for you now. Go ahead and try this homework assignment, and we'll see you later.